in this question, we're going to have simultaneous equations, and this is really a toughie. All right, so we're going to work through it, and hopefully you'll understand it better. So please take a photo of it that you can work through it with me. All right. So the question says, a police car is moving at a constant speed on a straight road. The siren of the car emits sounds of constant frequency. Each of two observers, A and B, standing some distance apart on the same road, record the frequency of the detected sound. Observer A records a frequency of 690 Hertz. Okay, so observer A is recording 690 Hertz. And observer B is recording a frequency of 610 Hertz. Okay, so let us see, what does the first question ask? Okay, state the Doppler effect. We're going to skip that because you're going to learn that off by heart for me, and you're going to get full marks for that. In which direction is the car moving? Choose from towards A or away from A and give a reason. All right, so let's have a look. So we said car A was observing a frequency of 690 and observer B was observing a frequency of 610. So obviously the police car is moving towards observer A. Why? Because it's experiencing a higher frequency, so more waves are striking the eardrum, so we're going to see it at a higher frequency and a higher pitch. So all you have to say is towards A, and the reason being is that the frequency is increasing as I move towards A, and there we go. Right, determine the speed of the police car and take the speed of sound in air as 340 meters per second, 6 marks. Okay, so glory be, that is going to be my level 3, level 4 question, and this one, as I said to you, is going to be a level 4 question because we're going to be working with simultaneous equations. So let us have a look. So all I can say is that when we are working with a situation like this, you take object A or car A and substitute all the values into the Doppler equation or into the wave equation. You do it for car A, you do it for car B, and then we're going to have a look at what we've got. So let's have a look at the question. All right, so start off by stating or writing out your equation. Remember, 1 mark is given to the equation. So even if you can't do this question, please write out the equation as given to you on the information sheet. So let me just make this line a bit smaller. There we go. And multiplied by the source, the frequency of the source. So now we're going to do it for car A. All right, so what do we observe? So the frequency observed was 690. They told us to take V as 340, so thank you for that. So there we go. VL is going to, in this instance, is standing still, so it's naught, so we don't even bother substituting in. So V once again is 340. Now we don't know what Vs is here. So because it's coming towards me, it's going to be minus Vs because the denominator here needs to get smaller so that we can observe this frequency at a higher frequency. And the frequency of the source, we don't know. So actually, we have got 2 unknowns. We don't know the frequency of the source, and we don't know the velocity of the source. And that is why we've got to use simultaneous equations. You're going to do exactly the same thing for B. So B, we know the observed frequency for B was 610. It was lower. It was moving away, is equal to 340. Now, because it got smaller, the denominator here is going to get larger. So we're going to add the velocity of the source multiplied by the frequency. So you see we've got 2 unknowns. In equation, let's call it equation A, I don't have the frequency of the source and I don't have the velocity of the source. Once again, in equation B, I don't have the frequency of the source and I don't have the velocity. So as a result, because I've got 2 unknowns, that is the reason why I'm going to have to look at simultaneous equations. So I'm going to extend the page and I'm going to continue underneath here Just realized I didn't give myself enough space. All right, so the easiest way is to make the frequency of the source the subject of the formula. So let us look at A. When I'm making it the subject of the formula, I'm going to take the 340 minus Vs. I'm going to take it across to the other side, multiplied by 690, is equal to 340 Fs. So what you can do now, obviously there's different ways of doing it. You can divide both sides by 340. So I'm going to have to divide this side by 340. And so I'm going to now erase this here. All right, so I've gotten rid of that. So I see for equation A, all right, this is equal to Fs. I'm going to do exactly the same thing with my equation B. So let us do the same thing there. So for equation B, we're going to go 340 plus Vs multiplied by 610 divided by, I'm going to do the same thing, 340 is equal to Fs. And now what can we do? We can now equate these two equations. Why? Because that is equal to the frequency of the source, and this one is equal to frequency of the source. So therefore, we can say 340 minus the velocity of the source multiplied by 690 divided by 340 is equal to 340 plus Vs multiplied by 610 divided by 340. My goodness me. All right, so that's a lot of maths. So what you're going to do now, you're going to try and simplify it as best you can. So what I would suggest, looking at it, I'm dividing both sides by 340, so they can be eliminated. We can get rid of that and just try and simplify, because now it becomes a mathematical expression. So far, you would have gotten the majority of the marks. So as long as you can get to this point, you are good. All right, then it's just a matter of doing the maths to get the final answer. So let us see what we get. All right, so those are going to cancel. If you wanted to simplify it further, you could actually say 340 minus Vs. All right, we can get rid of that and say it's equal to 340 plus Vs 610 divided by 690. So we can do that to simplify, and now we just need to do a bit of calculation. So 610 divided by 690 gives me 0.884. So we go 340 minus Vs equals 340 plus Vs multiplied by 0.884. You now need to solve, and you are going to solve for Vs, and I want you to go and check for me, and Vs should give you about a 20, I think my answer was about 20.93 meters per second. So if you can just do that, it will be great. All right, so please go and check me. So this was really just a tough one and a lot of maths, but you can do it.